Back to Saturn with Linda Spilker, this week on Planetary Radio. Hi everyone, welcome to Public Radio's travel show that takes you to the final frontier. I'm Matt Kaplan of the Planetary Society, and do we ever have a packed show? Started with Bill Nye's kudos to a team that has successfully tested a new kind of heat shield that could get us to the surface of Mars. Then it's time for one of our periodic updates from the Cassini mission's Linda Spilker. And boy, has there been a lot happening a billion miles away at Saturn. Emily Lakdawalla will explain a bit more about the recent smackdown at Jupiter. And Bruce Betts will give us an up-close look at more than the night sky this time. He's just a mile or so from the station fire, burning tens of thousands of acres in Southern California. Just barely enough time now to mention that Space Shuttle Discovery has reached the International Space Station and to send our condolences to India's Chandrayaan-1 team. Contact has been lost with that nation's first lunar orbiter. More details are in Emily's blog at planetary.org. Here's Bill.
Hey, Bill Nye, the planetary guy here, Vice President of the Planetary Society. Now, this week, the Augustine Commission's results are being debated. The former administrator of NASA, Michael Griffin, is complaining, saying that people must keep their focus on the moon. We can't lose our... Okay, and so on. But let me tell you what happened this week that was cool. NASA, with all the other stuff that's going on, all the other controversy, successfully launched and deployed the inflatable reentry vehicle experiment. This thing is an industrial fabric mushroom that inflated in space and came down through the Earth's atmosphere successfully. It had a little bit of spin to make it stable. And this is exactly the kind of thing that we need to do if we're going to go to Mars, whether it's with people or with robots. Because here's the thing. Mars has an atmosphere, but it's not much of an atmosphere. You enter the Martian atmosphere at any reasonable speed, you're going about Mach 10. By the time you get down deep enough in the atmosphere where you could fly around with your airplane or something, you're going about Mach 0.6. That's a huge range. And things get torn apart and they get really hot under those kind of aerodynamic conditions. But the inflatable reentry vehicle experiment was a success. This is the future. This is the kind of cool thing that NASA's got to tell the world about. Maybe it'll now be a reasonable cost to go up into low Earth orbit, grab debris, bring it down safely, burn it up easily. Then maybe we can go to other worlds like Mars and walk around and look at rocks. This could be cool. All from the IRV, the Inflatable Reentry Vehicle Experiment. Way to go, you guys. Good work. I gotta fly. Bill Nye, the planetary guy.
We check in with Linda Spilker at least twice a year. The Cassini deputy project scientist has been part of that magnificent mission since long before its launch nearly 12 years ago. The bus-sized spacecraft has now been exploring Saturn, its moons, and its rings for more than 5 years, and is in an extended phase called the Cassini Equinox mission. That's where our conversation started when I called her office at the Jet Propulsion Lab near Pasadena, California. Linda, welcome back and happy Equinox.
Oh, thank you very much. Yes, it's been a very exciting time here. The rings have been edge-on as seen from both the sun and the Earth.
And we have been talking about this off and on. Bruce Betts brings it up regularly in our What's Up segment. I don't know that you're entirely ready to talk about everything that Cassini has learned during this special time at Saturn.
No, we're still busy looking through the data, trying to understand what we see, and there'll be a lot more to come in the weeks ahead.
Okay, then we'll have to check back, either with you or one of your colleagues. We continue to learn an awful lot about the rings. Are the special conditions during the equinox likely to help us learn even more about these fantastic structures?
Oh, absolutely. With the conditions at equinox, with the sun essentially edge-on with respect to the rings, we have a chance to look for and get a three-dimensional view of the rings. Anything like warping in the rings or anything with vertical structure would cast shadows. In fact, it's just been fascinating to watch as the shadows of the moons and the tiny moons outside the rings grew longer and longer and started to go across the rings. And in fact, pretty early on, we made a very interesting find in that there's a gap called the Keeler Gap in the outer part of the A-ring. and there's a tiny moon Daphnis inside. Daphnis is only about 5 miles across, and it's keeping this 26-mile wide gap open. Its orbit is slightly inclined, and so what we saw as equinox drew near is that Daphnis is actually pulling material above and below the rings. So along the edges of the rings there are these structures. They're anywhere from a third to 1 mile high, which is more than 150 times more than the thickness of the rings, which we think is only, something like 30 feet. So here are these huge structures going up, towering structures casting these beautiful shadows with Daphnis sitting in the center, kind of having the prime seat. So sort of proof of concept that, yes, any additional vertical structures. We also saw an object in the B ring large enough to cast a shadow, and so we're continuing to look through the images and see what other interesting finds might be there with this unique geometry. It's unique. It only happens once every 15 years, and so we're just very lucky to have Cassini at Saturn for this time of equinox. And for this particular equinox, it turns out that Saturn was very close to the Sun, and so it really wasn't possible to do much in the way of ground-based observations because you wouldn't want to point your telescopes so close to the Sun to look at Saturn.
Yeah, not even the Hubble.
Right. Cassini had a ringside seat, you could definitely say.
You could. Better you than me. Our model of these rings seems to be becoming more and more complex the more we learn about them.
Oh, absolutely. Yes, the rings have gone from our ideas that they were single individual particles floating around to now the fact that they clump together and create these structures that we call gravitational wakes. And we're starting to think now and have been thinking that rings are an excellent model for planetary disks, similar to what formed our solar system. And so as we learn more about the processes happening in the rings, that's a really good analogy for processes that probably occurred within our own disk from which we got the planets, including the Earth.
And are probably, we know now, are continuing all across our galaxy and probably the universe.
Right. That's true. Other planetary disks as well. So what we're learning here at Saturn's rings will help us perhaps understand planetary formation elsewhere in our own galaxy.
Someday, maybe people are already saying this may prove to be one of the most important findings, conclusions that Cassini helps us reach based on the data it collects out there at Saturn.
Right, and I think there's still a lot more to learn. Certainly, every time we get a unique geometry, we learn more and more about these fascinating rings.
And they change over time, don't they? They evolve.
Right. In fact, the F ring in particular, we've seen a lot of change happening within Saturn's F ring, a narrow ring that's just outside the main rings. We've seen clumps come and go, jets, streamers. We're coming up toward the end of this year in a very interesting occurrence where the moon Prometheus, which is just orbiting just inside the F ring, will be at its apoapse, where the F ring is at periapse. And so we'll see lots of activity as Prometheus continues to distort and actually sort of start to dip into the F ring.
And give us definitions of those terms, please.
The apoapse of an orbit is the furthest. If an orbit is sort of egg-shaped or elliptical, apoapse is the point where you're the furthest in your orbit from Saturn. And if you're at periapse, that's when you're the closest to the planet. So if you get this anti-alignment, you can get Prometheus then at its closest point to the F ring.
All right, let's go a little farther out now and consider those moons, which are no less fascinating than what's going on with the rings. We'll get to Titan maybe in a minute, but since we last spoke, even more fascinating and very exciting data spewing out almost literally, right, from Enceladus.
Right. Yes, as we're getting a chance to try and understand the data in more detail, a couple of very interesting findings. One of those was the detection of sodium salts, essentially the equivalent of table salt and baking soda, in some of the tiny particles that are in the E-ring, which of course are coming from Enceladus's plumes. And these particles are almost pure water ice, but the cosmic dust analyzer is also able to pick up trace hints of these salts. And why salt is so important is it tells us that it's strong evidence for